Okay, this is a quick video to give an introduction to what we call proof by induction. So this is where we use this method following these steps, which are repetitive, to prove a statement given to us. So the statement might be something like this, okay? This is page 500, question 2. So it might be 1 plus 4 plus n plus 10 plus blah, blah. So that rule for that is 3n minus 2. It's the same as n over 2 times 3n minus 1. Okay, we'll get to that in a second. The important part I want you to do before you watch the video is pause it here and read this section in the book. Okay, so you're going to go to page 499 and read onwards. It does get quite tricky, but the good news is if you memorize these steps, okay, then you'll bag a lot of the marks. The problem solving comes near the end here, right? So if you just memorize these steps for proof by induction, first of all, I'll run through a couple of examples. So as I said, read the book, and then I'm going to do 2 examples with you and give you some work to do then, right? So the first thing we do when we have a question regarding proof by induction is to, let me see if I can split this. Okay, step 1, there's prove the statement is true for n equals 1, right? So I'm going to look at this part, which is the rule of the statement on the left hand side, and put 1 in. So 3 times 1 minus 2, okay, is 1. And I'm going to look at the right hand side and put 1 in. So 1 over 2 times 3 times 1 minus 1. So 3 minus 1 is 2. 2 times a half is 1. So we've proven it's true for n equals 1. So statement is true for n equals 1. Okay, that was step 1. Step 2 is we're going to assume it's true for n equals k, so any other number for n basically, right? So we're going to say that we're assuming that 1 plus 4 plus 7 plus 10 3k minus 2 is equal to k over 2 3k minus 1. We're assuming that it's true. It's going to help us with our next step. So step 3, if I go back to the steps here, I didn't talk you through them fully. These are in the book anyway. So first 2 steps, very straightforward. Prove it's true for n equals 1, which it will be. Assume it's true for n equals k by subbing k in for n, and then show the statement is true for n equals k plus 1, right? So this one gets a bit tricky, but just go with me. We're basing this on the assumption. Okay, so 3. What we're saying here is when n equals k plus 1, what we will have 1 plus 4 plus 7 plus 10, it'll be 3k minus 2. K plus 1 is the next one after k, isn't it? So if I put plus 3k plus 1 here minus 2, this becomes 1 plus 4 plus 7 plus 10 3k minus 2 plus be 3k. 3k times 1 is 3 minus 2 is 1, so it'll be 3k plus 1. Okay, so left hand side of the original statement becomes this when n equals k plus 1. Right? What we need to show is that this is the same as putting k plus 1 into this. So we want to bear this in mind. We want to show this k plus 1 over 2 bracket 3k plus 1 minus 1 as such. Okay, bracket should be there as well. Right, so that's what we want to show, that this is the same as that. So we're going to use the assumption. So we're assuming that remember up here, step 2, we're assuming that all of this is the same as that. So I'm going to replace all of this with that here. This becomes k over 2 times 3k minus 1 plus 3k plus 1. And we're going to try and show that that's the same as that. Okay? So here I'm going to just try and, this is where it gets a bit difficult, and with experience you get the hang of this, right? So going to put it all over a common denominator first. Right, so that's going to be, this bit stays the same, k times 3k minus 1 plus 2 times 3k plus 1 all over 2. Right, so that was already over 2, so I'm multiplying, I'm putting this over 2, so I've got to multiply the top over 2. Okay, so let's see what happens then if we multiply out the brackets. It would be 3k squared minus k plus 6k plus 3 all over 2, which is 3k squared plus 5k plus 3 all over 2. Okay. Now, all the while we're bearing in mind this is what we want to, this wants to look like this at the end, right? So if I factorize the top, okay, factorizing the top gives me 3k plus 2 times k plus 1. So you do the factorizing trick. I've just done that because I know it from experience, right? So you do 3 times, you know that trick there, 3 times 3 is 9, 1 multiplies to give 9, etc. Sorry, that should be 2 there, should it? Yeah, that should be 2 times 1 is 2, that's 2 there. So 3 times 2 is, so factorizing 3 times 2 is 6, 1 multiplied to give 6, etc. So here we are, we're at this stage now, and I want to bear in mind I want to get to here, right? So I've got k plus 1 and k plus 1. So although I'm trying to prove this, so let's put k plus 1 over 2, so that k plus 1 over 2, this bit outside, and this is the same as 3 times k plus 1 minus 1. Okay, so this is the tricks you'll recognize by doing these from experience, right? So go back over that. We use the assumption to replace this and add it to this, which is the k plus 1 value for the statement. And then we're manipulating that, trying to get this to equal that, basically, right? And down at the end here you have a little trick there. So 3 times k is 3k, 3 times 1 is 3, minus 1 is 2. Okay? So we've shown that, and then we write a statement then. So back to my steps, or these steps, not my steps. So we've done this bit, last bit is straightforward. This is the tricky part. You just make a statement, something like this. You'll see it in the book as well, right? So you'll say something like, since true for n equals 1 must be true for n equals 1 plus 1 equals 2, etc. Therefore, true for all values of n. You always finish your question off with something like that. Right? So that's one type you might get. You get one rule on the other side, one rule this side. Another type you could get is a divisibility question, right? So I've done this out already. So this is the one, this is page 503, question 8. I want you to read the examples and the textbook before going through this so you get some understanding. So this video is not the first thing you're looking at. Excuse me. Right, so you get something like that. So prove by induction that 5 to the power of n minus 4n plus 3 is divisible by 4 for n being a natural number. Okay, we follow exactly the same steps. Okay, so we prove is true for n equals 1. Right, so we're going to put 5, sorry about the camera, 5 to the power of 1, because n is 1, minus 4 times 1 plus 3 is equal to 4, which is divisible by 4. So we've proven that's true for n equals 1. We're going to assume it's true for n equals k. So from now on we're going to assume that 5k minus 4k plus 3 is divisible by 4. And then we get to the fun part. Based on the assumption, we must show that statement is true for n equals k plus 1. Okay. So we're going to put k plus 1 into there and try and show it's divisible by 4. So here's the method. Again, the good news is this is quite tricky, but you're getting better with experience. It's repetitive. Okay, so we're going to put k plus 1 in, so I'll try and keep it on the screen there. K plus 1 in for here, k plus 1 in there, right? And then in the end, I want to show it's divisible by 4. Now we're going to draw on our knowledge of indices here. Remember, a to the p plus q is equal to the a p q. Remember that from the tables? So we're going to change this. We always change this to, so 5 to the k plus 1 is the same as, sorry, I can write that as a to the p, a to the q. Yeah, sorry, that's not right there. It's a to the p, a to the q is equal to 5 to the k, 5 to the 1. Right, so we're always going to do that trick. Use our knowledge of indices, multiply out the bracket as well, so we end up with this. Then 5 is the same as 4 plus 1, it's 5 to the power of 1, and what you'll notice is when you do these questions is that this number here, which you'll break out, will always be another number. You're going to break it because it's divisible by 4, so it's 4 plus 1, so you're always going to have 4 here, or the number you're dividing by here when you break this up, okay? And this will come to light in a second. Leave the rest as it is. So 5 times 4, 5 to the power of k times 4 is 4 times 5 to the k. 5 to the k times 1 is 1 times 5 to the k. Right? So we're getting to the stage now where I know that 4 times 5 to the k is divisible by 4 because it's a multiple of 4. 4 times 5 to the k. Right? And then when you get to this stage here, you will end up with an expression with the number you're dividing by, in this case 4. So that's divisible by 4. What you want to do then is manipulate the rest of it. Well, it might turn out to be that anyway. Manipulate the rest of it so you're back to the assumption. Okay, so we assume that 5k minus 4k plus 3 was divisible by 4. So I've got rid of this bit here. So I've got 5k minus 4k minus 4 plus 3 here. So if I swap the 3 over, I end up with my assumption. Okay? So I know that this is divisible by 4 because it's a multiple of 4. I know this is divisible by 4 through the assumption, and minus 4 is also divisible by 4. Okay, so let's go back over that quickly. Same steps. Prove is true for n equals 1. Assume is true for n equals k. Then we put k plus 1 in for whatever value of for n, and use this trick with indices. Multiply the brackets. Split the indices so it's divisible by the number we're looking for, in this case 4, and then manipulate the rest so we end up with the assumption. Alright? So then we can say, since 4 times 5 to the k is divisible by 4, 5k minus 4k plus 3 is assumed divisible by 4 from step 2, and minus 4 is divisible by 4. Therefore, 5k, this is divisible by 4, is true for n equals k plus 1. Therefore, true for all values of n. Okay? So yes, this is all very new to you, but as I said, the good news here is that the steps are very repetitive, and the more you do, the more you'll see the tricks of the trade in terms of this sort of section here. Okay?